Hello. This is really exciting. Thank you for doing this, by the way. I'm Andrew. Let me go a little bit over the agenda for today. I'm going to give you a lovely backstory of how I got where I am today. I'm going to talk a little bit about the primitives that Finagle and Finch give you, and how I went about trying to build some abstractions on top of that, and maybe ways that you might be able to do that as well, so that we can have some really nice functional Scala idiomatic libraries out there to build our services on. It'd be really neat. And then we'll talk about those abstractions. So first, a little bit about me. I work at Lookout, which is kind of weird that I'm here. There's a little bit of an imposter syndrome because we're a Ruby shop. But we're also like a really weird one. We're a JRuby shop. And so the way that I got to Scala was via Kafka, writing a JRuby wrapper on that. So here I am. Glad to be here. Also I started functional programming study groups there. Those are really fun. I also am part of our diversity committee. For this 6-month stint, we're really focusing on trying to increase women in our engineering organization. I'd love to talk with anybody that is passionate or has ideas or is doing something interesting. Maybe we can collaborate. So come talk to me about diversity or functional programming. Surprisingly, even though we are a Ruby shop, there are some really exciting things happening really soon at Lookout. One of the teams I'm moving from is currently looking at using Finagle to build out the entire brand new platform infrastructure. And the team that I am moving to is taking a functional approach to infrastructure and deployment, which is really neat, backed on like Nix OS and everything like that. So come talk to us, and there's some really weird hair-colored people over there that I'm with that you could also talk to. They're with me. Previous to that, I did my thesis on static analysis of Dalvik bytecode for malware detection at the University of Utah. I did that in a functional language, but it was dynamically typed, so that was Racket. And then this is my sales to you, is to not listen to what I'm talking about. This is my first conference talk, so I hope it's not my last. I am not an expert at all in Scala, nor in typed functional programming. I love it, I'm really passionate about it, but much like my dancing style, I probably won't get paid too much for it. So mostly this talk is about lessons that I've learned building an idiomatic Scala open source functional programming library that you guys can contribute to or deface. You might not care too much if you're a Java developer, because I don't think any of this actually works in Java. I think you need a better compiler. Oh, sorry. Okay, everybody leave. All right. Here's some context. It's a story as old as time. A well-intentioned group of people start using Rails, and then they use it some more because they love it so much. And then they keep using it until one day you realize that you've built a monolithic Rails service that falls down under the success you've had. And of course, you know the answer to this. Service-oriented architecture, because that is less complex. The idea is really good, right? The idea is that you're going to kind of remove the complexity from this giant monolithic server and make these small little testable things that you can reason about. But until you actually start doing that, you don't realize that, oh wait, now we're really complecting the orchestration of these services. And things just as simple as authentication from like 2 different types of clients, like web browsers or devices, get way more complex when they have to talk to a whole bunch of different services. So you start, it's kind of a mess. And as we saw from Marius's talk, it's a mess that everybody has felt. And so I want to talk a little bit about some of those, the orchestration part of what this library does. It focuses on composing sessions, so the ability to sort of have a caching layer of data that you might pass around, maybe authentication data, between disparate microservices. And then also the idea that somehow we can have a pluggable authentication mechanism. Because we have enterprises coming on and things that we might need to support OAuth 2 and SAML and have like a single sign-on for all of these sorts of things, and what's sort of a functional approach for doing that. And also utilize some of the really nice primitives that Finagle gives you for service discovery, like the really cool things we saw on DTabs and things like that. So now you have context. We actually did implement this as a first version in Nginx and Lua. It is as scary and messy as it sounds. It's an open source project. You can see it. I don't know if you'd be able to use it. It's pretty specific to our implementation. But it was a really good, it's what's currently running in production right now. But we're really close to getting that Finagle one out. Let's talk a little bit about what I thought about in designing a library that could be reusable, which was one of the key problems with the Nginx Lua version. It was so specific to us that there wasn't really a use case for anybody else, and it was really, I don't even know that you could use the other one in any other ecosystem. So functional programming actually gives you a really nice approach to take, and so I want to take a little journey through how you get there. Inheritance is not a great API for your user base. It seems good, right? You create like your mammal or whatever that might go to your shoe store. Yes, I'm going there. So yes, you can have shoes for humans and cats, and then they can get their kicks. But what happens to all of your friends, like who have birds and lizards and like velociraptors that also need shoes? It sort of breaks apart there. So there's this great idea of interfaces. So instead of defining a really general type and then accepting all the subtypes, you're specifying a very specific thing and then allowing more general things to come in, which is a nicer place to be as a user of your library. So essentially, anything that implements feet might be able to get in there. Of course, yards also contain feet, and I don't think they wear shoes. But yeah. So in OO, there's this pattern called the adapter pattern. It's neat, but again, it sort of fails to meet sort of the requirements of a good use case or a good user experience because interface membership is determined at the definition of that class, right? And so like Rubyists are like, yes, we have the answer to this, monkey patching, because like that's what you do, but it makes you a horrible person, and nobody wants to be a horrible person. And so, well, most people don't. So I don't. But yeah, I mean, monkey patching sort of handles the case of ad hoc polymorphism that you want, like this ad hoc ability to add functionality to something that didn't have it, that you don't have access to the definition of, right? So like you can monkey patch string, and then everybody cries. So in functional programming, we have this thing called type classes. And this is a really, really neat approach to the same idea as interfaces. And the spirit, like the unbridled, just naive spirit of monkey patching comes into statically typed, like at compile time. ad hoc polymorphism, which is awesome. So yes, this talk is going to be about how I modeled our sessions, the ability to have any type of session using type classes to be stored, to store that data in any backend service. And so yes, so web sessions are something that generally, we have for a web browser, we have a cookie on the web browser that has some sort of unique identifier that then we hold state on the server for. And so this is the definition basically of what I came up with for sessions. The session ID is interesting. Like, we're a security company. There's a whole slew of really interesting things we can do with this library towards encryption and cryptographic verification that I'd love people to build things on. But even the session ID is cryptographically verifiable and expires and everything, which is neat. But the data is just this thing, whatever it is, whatever you want to put in there, you can. And so a simple interface for a store, right, would be something like this, just a function that takes a key in a store and returns, if it exists, a thing, a hydrated thing. And if you wanted to store it, you have your key and your thing and a store, and it succeeds or fails. But unfortunately, like, this sort of falls apart when you have like a data type of A and the store is requiring a B, and like these two things, A and B, aren't the same. And so what do? You want to define some functions that allow you to shove that data into the store. And this is where type classes are really great, because basically you say, okay, I'm going to come up with some laws that you have to prove to me that you've implemented, and once you prove it to me, then everything's great. And so these are the laws. This is all we really need to do. We need to have some way to turn the data into the thing that the store wants to take. And we also need a way to take what the store is going to give us and hopefully turn it into a thing that we're expecting from a session. And so we can define like a general encoder law, right? So you want to encode type A into B and decode B and potentially get A. And so Finagle already has this primitive type called buff, which is a wrapper around byte arrays, and byte arrays are pretty neat ways of serializing things. Not always the best, but they're pretty neat. And it has helper methods for things like string and UTF-8 sort of things, and unsigned integers and things like that. Excuse me, I'm starting to make really fun sounds. All right, so we can actually make this a little bit simpler, right? We create some sort of encode session, which we could just do as sort of a type alias, or actually make it our own trait. So by using buff, we've solidified, okay, we're a Finagle library, we're going to say that anything that we're going to send to it needs to be encoded as a buff. And it makes things a little bit more simple, I think, in terms, like, it's a little less flexible, but it makes it easier for your users. So I made that opinionated design decision to say, yes, you must be able to serialize into a buff. And so actually, so now all I have to do is provide proof that the thing that I want to store can be stored as a buff. And so as one of the primary use cases of this system is when a user tries to access an authenticated endpoint and they get a 401, we save where they tried to go so that when they log in, we can redirect them, right? So we want to be able to save a request. And so I'm proving to the compiler that now I can save a request with this. May not be the best code in the world, but it works, and it tells the compiler that, hey, I have a way to go from A to B and B to option of A in terms of the request and buffer. In my first implementation, I didn't know about some of those helper functions, so I took the raw netty version and turned it into JSON and then turned JSON into a byte array. It's fantastic. The code's still there. And then you actually use the type class, right? So we have these things in Scala called context bounds. It's like syntactic sugar to having some sort of implicit evidence at the other side of your function. But this is basically the new API for a session store. And you can implement it using Finagle really easily with their Memcache client. And like it's just as easy to do a Redis client as well. I mean, it's like that's one of the really great things about being in the Finagle system is that you have access to a generic RPC system. So whatever store you want to use, like it's fairly straightforward. And so yeah, what happened? So now we have a session in a session store, and they only care about the contract of the two functions, and not actually what's in it. Just that we've done our job to prove that we can shove A into that store. And I have a challenge for you guys to have a little bit more fun with the functional side of things. Session, as it turns out, looks a lot like it could be put into a functor. And if we can put it into a functor and use the free monad and implement an interpreter, now we can have like a purely functional like value for get and put, and like we can have more compile time guarantees of really neat things, and then plug in a Finagle backend store. There is an issue on the GitHub page that is asking for somebody to work on this, if I don't get to it first. So we also have authentication as a type class. This is a little hand wavy at this point because we only have one real use case for it. Right now there's basic auth and then our own internal JSON Web Token based thing, but really like to support like Finagle OAuth 2 and things. We just don't have a use case yet for it. So I want to talk a little bit about the primitives from Finagle and from Finch, and how you can use them to build on abstractions. So Finagle has two basic primitive types, a service and a filter, and they're both basically partial functions that you can combine with and then to build some really neat flows. Finch takes the abstractions that Finagle has, and its sort of messy HTTP implementation a little bit, not as nice to work with, a little messier and kind of working directly with HTTP, and builds higher order wrappers for these things, so that you can create these really nice DSLs that you find in Finch, and have compile time guarantees that you can automatically derive a partial class of some sort of JSON object, and like all the magic that Travis and Vladimir have been doing, and so this is a really like a great place to just read code and learn. I would highly recommend looking at the Finch code base. It's organized and very, very straightforward to learn a lot of functional programming from that. So one of the use cases for this service as well is the ability to be able to infer or determine what service it is that you're trying to contact, so it can do some injection of headers and put in like the right token into the right place and everything. And it's very easy to do that with like conditionals and looking at requests. But using routers from Finch, it becomes a lot nicer of an ecosystem to live within. Because routers are really just a request to some sort of option underneath, a wrapper on that. So you have this really nice DSL from Finch. If you didn't see Finch yet, you should really check it out, of a way that you could define a REST API. Using these primitives, we have this idea of any service that's behind our system either needs to have its path, like a name for it, a symbolic name like in dtabs, right? But it's actually baked into the path. Or we can infer from the subdomain that you were going to this is where you meant to go. So we need to encode, like we can encode that as values here. So this path-based service, we can just use this extractor type, which is a type of router where you can actually like take the value with you along. Same thing with a subdomain. We create a new extractor that looks at the host. This doesn't do proper like doesn't do proper matching there. But basically the really neat part is that you can encode in values that guarantee at compile time that you're doing things in the right order, what you would have had to do sort of like this in a really ad hoc way and in a not composable way. And so that's really awesome. And if you think that's awesome, I think you're awesome. I think you're awesome anyway. You should come and talk to me anyway. And let's skip ahead. Things that we do sessions, we have the authentication, and we have encryption per session encryption for data at rest, which is like super, super neat. There's an RFC that I wrote for that I'd love to have like security experts look at because I think it's the shit. Things that it's about to do, I'd love to have CSRF via double submit cookies like as a module that you could just import into some Finch project because that's what you need. And then also the periodic, we have signing keys and things. So if you want to help, the project is called Border Patrol, for better or worse. And if you don't want to help us, then help the community and build these neat abstractions and modules for Finagle and Finch yourself. So thank you.
Thanks, Andrew.
Thank you.
The question is, when can we see lockout in the Finch adopters list?
When can we see lookout?
In the Finch adopters list?
Oh, when we ship to production, which is very, 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 very soon.
Cool. We're waiting for you.
Yes. Thanks.
Any other questions? Great. Thank you, Andrew.
Great. Thanks.